Alrighty, in this video we are going to be doing optimization in terms of triangles, aka let's say that we're using Pythag as our equation. Which one? We'll find out. So for 4a, we want to write the length of the hypotenuse as a function of x, given that we have a right triangle formed in the first quadrant by the x and y axes, and it passes through the point 1, 2. So we have x, and then we have y here. All right. Now, if I want to find the length of L, we're just going to use Pythag. The problem is we want it in terms of a function x. So I don't want y squared. We don't want her. So instead, what we need to do is think about how we could rewrite y in terms of the equation right here. AKA, we could find the equation of this line. Now, in order to find the equation of this line, I kind of have two things. I have 1, 2, and this could be used with 0, y, and this could also be used with x, 0. What I'm going to do here is think about how I can find the slope of this portion and how I can find the slope of this portion by using this and this here. So using 0, y and 1, 2, I'm going to have y minus 2 is equal to 0 minus 1. Using 1, 2 and x, 0, I'm going to have 2 minus 0 over 1 minus x. Solving for y, so I'm going to go ahead and do y minus 2 is equal to negative 2, 1 minus x, and then I'm just going to add 2. Now, to make my life easier, I do like my coefficient to be positive, my variable here to be positive. So I'm going to factor out a negative 1. If I factor out a negative, I'm going to get x minus 1. I have a negative 2 on top, so the negatives will cancel out and go away, meaning that I'm just left with an x minus 1 on the bottom and a regular 2 on top. So then if I were to plug this back into my y square, I'm going to get x squared plus 2x minus 1 plus 2 squared is equal to L squared. And then I am going to take the square root of this since I'm technically solving for L. That's going to give me this lovely mess right here. And you know, it's okay. You don't have to clean it up. The graders will be okay if you just leave it like this. I'll be okay too. So that's my answer for part A. Now for part B, it says find the vertices of the triangle such that the area is a minimum. So in order to do that, since we're talking about the area of a triangle and we want to optimize that, that's going to be my primary equation. So my primary is going to be 1/2 x times y. Well, guess what? We already have my secondary equation, aka this thing that we just found earlier, using slope. So I'm going to be using that and substitute that for y. I'm going to simplify this a little bit by multiplying by 1/2. That's going to give me 1 over x minus 1 plus 1. And then I'm going to multiply by x. So that's going to give me x over x minus 1 plus x. And now we're just going to take the derivative with respect to x and call it a day. So we're going to be using quotient for the first term. Not fun, but it is what it is, huh? We have low d high minus high d low all over low square, which honestly wasn't that bad, I guess. And then we have 1, since my derivative of x is 1. We're going to set this equal to 0. But first, I think we could simplify the numerator. I think that should be easy. X minus 1 minus x, which is just negative 1. So I have 0 is equal to negative 1 over x minus 1 squared plus 1. I'm going to move the 1, negative 1 over x minus 1 squared to the left is equal to 1. I'm going to multiply that. And then I'm going to take the square root. And then I'm going to add 1. If I do that, I'm going to get x is equal to 0 and x is equal to 2. Here's my problem if x is equal to 0. If x is equal to 0, then I'm going to have 0, comma 0. That's not going to make a triangle. So that's going to be gone. She's gone. We don't want her. So now I am going to make my little sign chart at 2, but being careful that I don't pick anything before 0 and at 0. I'm also going to be careful because I don't want to pick 1 either, because 1 is going to give us an undefined value. So we don't want her either. So instead, we're going to have to pick something like 1/2 and see what happens there. And then we're also going to see what happens if I pick something like 3. If I pick something like 3 here, I'm going to have negative 1 over 3 minus 1 is 2. 2 squared is 4. Negative 1/4 plus 1 is going to be a positive number, so this is going to be positive. And then if I pick something like 1/2 here, I'm going to get negative 1 and then negative 1/2 squared plus 1, negative 1. This is going to be negative a 4, no, positive a 4 plus 1. This is technically negative 4. Negative 4 plus 1 is negative 3, so this is negative. Which should make sense in our context because we're looking for a minimum value. So this means that we're going to have a minimum whenever x is equal to 2 here. So we have a minimum when x is equal to 2. We can do that in a different color. Let's do yellow for the LOLs. Sorry, guys. And then what we're going to do is plug in x is equal to 2 into y. So 2 minus 1 plus 2, 2 plus 2, so that's 4. So this means that my vertices are going to be 0, 0, 2, 0, and 0, comma 4. So these are going to be my vertices where my triangle is a minimum. Wow, that was a process. All right, in the next video, we'll do number 5 and see how that goes.